Natalie, could you do me a favour and just tell the tech guys that the screen share is locked?
They're working on it right now, Adrian.
Thank you very much.
Technology is never easy, isn't it? I'm sure you had lots of experience with challenges that they present.
Indeed, but this one's going to make me run out of time.
Other presenters have made it easier on you, Adrian.
Well, let me just start talking a little bit while we're waiting for this to come up. Because I think most people are aware of what the opportunity is, and you probably wouldn't be attending this conference if you didn't understand the opportunity. It's all about batteries. It's all about green energy. It's about the backup for renewables. It's about the Paris Agreement and what can be achieved under that agreement, and where we're going with energy management on a global basis. We're seeing some really interesting changes that I want to talk about, and those changes revolve around a fairly dramatic change in battery chemistry, and it's something that we've been telling the industry for a long period of time. We simply can't continue to keep doing what we're doing, and that's not only with respect to the type of battery chemistry that we have available, but it's also looking at the sustainability of those materials and the recycling of those materials. But I think we've seen a very interesting shift in recent times, and when I say recent times, I'm talking about the last 2 or 3 months, where there's been a global move away from lithium cobalt bearing batteries. Now, for a long period of time, lithium ferrophosphate, LFP, which doesn't rely very heavily on critical materials because its principal constituents are lithium, iron and phosphorus, for a long period of time that has been utilised fairly heavily in the energy storage industry. And the reason it has been successful there is its low cost, because you don't have some of those expensive metals like nickel and cobalt. It has terrific longevity in that you get about 3 times the number of duty cycles out of LFP than you do out of NCM, and it's remarkably safe. It doesn't suffer from thermal runaway, and as a consequence, if you look at Chinese policy up until about 2 years ago, if you're going to move people in public transport that was powered by batteries, or for that matter goods, you weren't allowed to use NCM batteries. It had to be LFP, and that was a safety consideration. The rest of the world, however, threw safety to the wind and said, well, we're concerned about range anxiety, and what we want to do is have our Tesla go for a little bit further, and we don't care what the cost of that is, either in terms of capital or safety. And so the rest of the world didn't adopt LFP in transportation applications until very recently. And we've seen something, I'd love to bring up some of these graphs, but we have seen something that's emerged recently in the last couple of months, and that is, for the first time, the production of LFP has eclipsed the nickel and cobalt battery variants in China. So we are seeing a dramatic shift, and that is backed to a large extent by changes in philosophy. And you've got companies such as Tesla, where they've announced all of their energy storage products are moving to LFP. Their production of vehicles out of China is largely LFP. They're being exported to Europe, where they're going head to head with BYD. BYD is probably about the 2nd or 3rd largest battery producer on the planet. And they have announced that they're not going to produce any nickel and cobalt batteries anymore. They're going to be all LFP. They are producing vehicles for the European market that are going head to head with Tesla, and we have the likes of VW also announcing that all of their entry-level vehicles are going to be LFP. So really, LFP is taking over in the vehicle market. There are a couple of legislative things that will also, I still don't have a screen share, which is a shame. Also means I can't read any of my notes. But yeah, so we're seeing a major change, and some of that's going to be driven by legislation. There's draft legislation in Europe, draft legislation in the United States, and also in China, which will require fire protection to be put on battery packs in motor vehicles, those battery packs being NCM and NCA, nickel, cobalt, manganese, nickel, cobalt, aluminium. The reason behind that is because of the thermal runaway that you do get, and we've all heard about the battery fires in various types of vehicles and other locations, I might add, in the recycling of those batteries. So that legislation will, of course, bolt fire protection onto the top of those battery packs, and that takes up extra volume, and as a consequence, the energy density at pack level will decrease. Now, if you look at the attributes of LFP, I've mentioned the fact that LFP batteries don't suffer from thermal runaway. They much cheaper to produce. They operate over a broad temperature. You don't even have to have a battery management system. You can make them a direct swap for lead acid batteries if you so desire. So they are much more versatile. What's the downside? You know, that really sounds like the perfect battery material. The downside is energy density. And the energy density of LFP is about 30% less than the nearest competitor, being NCM. So what can you do about this? There are a number of things that you can do, and they include, of course, changing the composition of the LFP material. Incidentally, the reason the LFP material is stable is because of the crystal system that the cathode powder crystallises in. It's in the olivine system, whereas the other batteries are spinels, they're oxides, and the bond strength on the spinels is far less. So if the spinel starts to decompose inside of a battery, it releases oxygen, and you've got electrolytes there that are organic solvents, and they burst into flame inside the battery. And once you get one of them going, it's like a domino effect, and the whole lot goes. Not a significant danger in LFP batteries. So what can you do to increase the energy density? You can add base metals to the LFP, and it still crystallises in the olivine crystal system, and as a consequence has all those inherently good features. No thermal runaway, longevity, cheap to make, of course, because you can still use bulk commodities in those materials. And as a consequence, you can increase the energy density of LFP by around about 25%, bringing it just about up to the same level as NCM. Now, we have a number of research programs going that improve sustainability and will make these materials competitive with other materials. Let me talk firstly about the sustainability in spodumene, and one of the processes that we have for recovering lithium out of spodumene. The real shortfall of the spodumene industry is legacy processing technology downstream there, the conventional converters in China. Oh, we've just about finished the presentation now that we've got this. However, I'll just scroll back. I don't have any screen control either. Can we scroll back one? Oh, look, I've mentioned that, and the fact that LFP is overtaking the other battery chemistries, and will continue to do so. And I think about 5 years out, we're likely to see LFP up around something like, still got no control, something like 70% of the market. Let's move forward. and have a look at the supply chains. And the supply chain is pretty interesting from a point of view of energy, in that they burn enormous amounts of energy. And if you continue with nickel and cobalt, quite clearly you can't change the geometry of the supply chain on a global basis, because you can't move the nickel and cobalt deposits. And as a consequence, you've got very complicated supply chains. If you go to LFP, and bear in mind that you've got iron and phosphorus available in large quantities just about anywhere, if you go to LFP, all you've got to do is move the lithium. Now, you need to move that as a lithium chemical, best produced close to the source, rather than doing what happened here a couple of years ago when there was a shortage of lithium and there were companies moving literally 100 tonnes of direct shipping ore at 1.2% lithium to China to produce 1 tonne of lithium carbonate. An environmental disaster, and I don't know how you can make money out of it. But let's move forward. So you can do all these things. You can go to LFP. What about the consumer moving forward? LFP is going to be the first battery material to break the magic $100 a kilowatt hour barrier in terms of storage, and that's the tipping point for consumers to go from internal combustion engines to battery-powered vehicles. That's the point at which the total ownership cost is about the same, and LFP will lead the field. And if indeed we move more dramatically from NCN to LFP, of course that curve will drop because the price will get cheaper. Moving on. So we've actually built our business around the lithium supply chain, or the battery metal supply chain. We've developed a whole suite of technologies that provide vertical integration and dovetail one into the other to minimise the number of processing steps. Forward, forward, forward. Look, I apologise for the animation, because when you're telling people to flick the slides, it just doesn't work. But if you combine all these technologies, what you get is superior resource recovery, fewer steps from mine gate to motor vehicle, and really you get a better battery. Next slide. Next slide. I want to talk about the wasteful miners, the spodumene miners, and the fact that the design parameters that they had in their feasibility studies were nothing like what they achieved. Next slide. And that's because there's almost a glass ceiling with respect to processing spodumene if you feed it into legacy technologies such as conventional converters. Conventional converters are designed to take relatively coarse material. They have solid flow running downslope, gas flow running upslope. If the particles are too small, they get blown out. Physically, you can't process them. So what we've done is, next slide, has created a hydrometallurgical process that just thrives on fine material and has the capability of picking up much of the loss that you see from mine sites through to concentrators. Next slide. So that process, no roasting, it's a caustic conversion, thrives on fine material. It doesn't have the problems with some of the byproduct production, sodium sulphate in particular, which may be the Achilles heel of the conventional converters, benign tailings. But what I really love about this is we've tailored this process to produce a lithium chemical, lithium phosphate, that goes directly into the production of LFP. Now, if you look at current producers, and probably Dynanonic in China, the largest producer of LFP in the world, they would prefer to use lithium phosphate as a feed source to the production of LFP, but it's simply not available. So they have to buy hydroxide. The hydroxide gets converted to the phosphate. The phosphate then goes in and produces the LFP powder. Why didn't the legacy producers produce the chemical that the battery producer wanted in the first place? Well, we can do that. Next slide. Oh, just scroll back a bit if you would, please. And we've already issued the first licence for this, and we're building a pilot plant in Sydney in conjunction with ANSTO. Next slide. Then we can take that lithium phosphate material into VSPC, our cathode powder division. Next slide. Next slide. There's a shot of the pilot plant. We produce what are simply the best LFP cathode powders in the world. Next slide. We have a partnership with CSIRO funded by CRCP to produce a rapid charge discharge battery for public transport use. Next slide. And very importantly, we have a research project going producing LMFP, lithium manganese ferrophosphate, and this is the way you get to the next generation of cathode powders, and you increase the energy density at marginally increased operating cost to produce a better cathode powder. Next slide. These are the characteristics of your standard cathode powders, generally expressed in a spider diagram. You'll notice the shortfall of LFP being energy density. Next slide. But if we throw in a bit of manganese, you fix that and you end up with properties in just about every respect that are superior to NCM. So why wouldn't you use this stuff? Next slide. Next slide. This is a standard LFP powder manufactured by VSPC. Next slide. This is LMFP, and the difference in energy density to a large extent is the area under those curves. Next slide. So if we look at the voltage difference, which to a large extent determines the energy, next slide, and we look at the difference in area on those two curves, you can see quite clearly that if you go for LMFP, you can get that quite astounding increase in energy density. Now, a number of companies have tried this and failed. It's not new technology. LMFP has been around for about 20 years. The issue is quality control on manufacturing it. Can you produce the same stuff day in, day out? We have patented nanotechnology for producing these cathode powders, and they are very simple and they are capable of providing the ultimate quality control. Next slide. Next slide. So we've completed pre-feasibility on the production of cathode powders. We've done a trade-off at various locations, but from a financial point of view, you can see there that for 10,000 tonne per annum production of LFP, NPV of over 250 million US, a really healthy internal rate of return, quick payback. Total cost of building a plant, a bit over 100 million. So, yeah, this is a really robust project. Next slide, please. So, where's the company going in the future? I mentioned we have four major divisions. We've got raw materials, lithium chemicals, which includes the Lena process, the battery division, which is production of cathode powders. Incidentally, we can take material right through from spodumene through to the production of batteries in-house on a pilot scale. So we've got the whole supply chain sitting there that we can utilise for test purposes. Raw materials, which was our exploration division. Next slide. To a large extent, we've sold off as various joint ventures where we retain equity in the public companies running the programs and free carried direct project equities of 20 to 30%. For those of you who want to get onto the next Julimar, not the next slide, back one please, thanks, onto the next Julimar, we have it in the package. The package is being sold into Charger Metals. The prospectus has been lodged. Lithium Australia shareholders have a priority entitlement, and that priority entitlement closes in a few days. So if you want to avail yourself of one of the really hot areas in battery materials and precious metals, have a look at that. Next slide, please. Lithium chemical division I've mentioned, which is the extraction of lithium from a number of sources. I've only mentioned spodumene because I think really to get sustainability in the industry, the spodumene producers have to do something. They can't keep throwing between 50 and 30% of the material into tailing dams, and Lena gives them the ability to recover much of that. And as I mentioned, first licence has already been signed on that process. Next slide. VSPC, I've mentioned the cathode materials. We've completed pre-feasibility, going into definitive feasibility, talking to financiers about future development on a commercial scale. Next slide. Saluna, that's our battery sales division, which sells into energy storage. Next slide. And lastly, closing the loop and creating the ultimate in sustainability is EnviroStream Australia. It's the only mixed battery recycler in Australia. That's based in Melbourne, commercial plant. We take all types of batteries. The main target, of course, is lithium-ion batteries, and we're going to see a major change in the industry here with respect to lithium-ion batteries shortly, and that's the introduction of a stewardship scheme that will charge a levy at the point of sale of a battery. That levy will go back through the Stewardship Council to those collecting and recycling the batteries. It'll commoditise batteries at about $4,500 a tonne, and just about overnight triple the bottom line on that business. Next slide. So, corporate snapshot, there we are. Market capitalisation a bit over 100 million. Plenty of cash in the bank at the moment, fortunately, to run our projects. Doesn't mean if you've got deep pockets we can't give you investment. There are investments available, of course, in the holding company subsidiaries and at project level. Next slide. But all said and done, that's what we're all about, developing the shortest supply chain from mine site through to motor vehicle and developing the integrated systems to produce sustainable lithium-ion batteries. My apologies for one, not being in attendance, two, not having a presentation that worked, and three, probably running a little bit over time. I'd like to thank Paydirt, however. You know, they put on a great conference and under fairly difficult circumstances today, so it's a great credit to everyone involved. Thank you very much.